All right, today we're in section 2.1, Properties and Operations. Okay, it's a long lesson, so we're going to divide it into two parts. The first thing we need to write in our notes is some key words for each number property. That the key word for the commutative property is order. And what that means is it doesn't matter what order I add or multiply in, it will not change my answer. So I can change the order to make it easier to solve and even solve using mental math. The associative property says that I can change my grouping. This is especially helpful in expressions where I don't have like terms. So like terms is something we'll go over later on in this lesson, but I can group the like terms together so that I can simplify it. You guys actually learned this back in chapter 1 when you grouped your positives and negatives together when you did the mean. You guys remember that? So you've already done a little bit of the commutative and associative property, and you might not have even thought about it that way. Inverse property deals with opposites. We also already kind of touched on this in chapter 1. Remember when we did absolute value and opposite value of a number? So what's the opposite of negative 5? 5. So here's what this property says. You take a number and its opposite, and the answer is always 0. Or you multiply a number and its opposite. So the opposite of 1/5 would be what? What's the opposite of 1/5? 5 over 1. I flip it. So when I say opposite with multiplication, I'm talking about the reciprocal. We'll talk more about that in a minute. And then the identity property, that is basically a reflection. That's why we call it the mirror property, because you take a number and you add 0 to it and it's just that number. Or you multiply it by 1 and it will be just that number. And you'll see that in a sec when we go over the property. So first things first, the commutative properties. This is on the handout that I gave you. All right, so if you could just go ahead and get out a highlighter. I want you to just highlight a few things on this paper. Right, this means that I can multiply or add numbers in any order. All right, so here's what I need you to highlight under commutative property. Any order. Highlight that on your paper. Any order. All right, and you see the same examples on your paper that we have up here on the screen. It doesn't matter if I do 4 plus 3 or 3 plus 4, my answer is still 7. Same thing goes with the multiplication. Commutative property can be very helpful, and you'll see a little bit more of an explanation of that in a minute when we get into example 1. But can definitely be helpful in making problems easier to solve. Did I say possible to solve? No, you can still solve a problem without using the number properties. It's just going to be a lot more difficult. If you know the number properties, it can make your life a lot easier, even if you're using a calculator. All right? Now, with associative properties, I can change the grouping of my terms and it won't change the answer. It doesn't matter if I group 3 plus 4 and do 7 plus 5 is 12, or 3 plus 9 equals 12. It doesn't matter. My answer is still going to be 12, and that's all that matters. Does not change my answer. Same thing with multiplication. 12 times 5 is still 60, or 3 times 20 is still 60. So again, changing the grouping of my terms doesn't change my answer. Now you might say, well, I don't really see a whole lot of point in that. And you're right, maybe with this specific example, you know, these numbers, but when you throw in variables in the mix, like we're going to do in example 4, I believe, it can actually be helpful to understand how you can change the grouping of your numbers. All right? All right, now with inverse properties, the inverse property of addition says, and we've already touched on this, that the sum of a number and its, highlight this on your paper, opposite is 0. Now on your paper, I also called it what? The additive inverse. You need to know that when I say what is the additive inverse of, say, 4, I'm asking for its opposite. So if I say, what is the additive inverse of 4, you would say negative 4. It's just a fancy word for the opposite. Okay? So what's the additive inverse of 6? -6. So on a quiz, if I were to ask you in a fill in the blank, what is the additive inverse of 2, you would be able to answer it? Say -2. So no math to do, you just have to recognize that term. All right, now with the inverse property of multiplication, the product of a non-zero number and its reciprocal is 1. We also call that the multiplicative identity, and you see that underlined on your notes. Okay, the multiplicative identity is another word for reciprocal. It's just something you have to memorize. So if I said, what is the multiplicative identity of 4/5? I would flip it and I would say it's 5/4. You see that? So what's the multiplicative identity of 2/3? 3/2. 3/2. Austin, you with me?
Yes, ma'am.
Okay, so those are some terms for those properties, the first 3 properties. Property number 4, the identity properties. The sum of a number and 0. The sum of a number and 0, which is the additive identity, okay, is the number itself. With multiplication, the product of number and 1, which is, again, the multiplicative identity, okay, is just the number itself. The reason why we call this the mirror property is because it's basically just a reflection of that number. Whether you're adding 0 to it or you're multiplying it by 1, the answer is just going to be that number. All right, so the identity properties. Here's how you're going to see this on a quiz. Okay, this is at least one way that you would see it on a quiz. You'll be given some scenarios. Actually, we'll skip to that in example 3. I'm getting ahead of myself. But you'll be given some scenarios where you basically just see an expression and I say, what property is that? And then you can answer that. Does that make sense? Okay, so let's see how this applies. Example 1. It says you buy, read up here with me on the screen, you buy a portable CD player for $48, rechargeable batteries with charger for $25, and a CD case for $12. Find the cost. Well, the first thing I've got to do is figure out what operation do I use here? Addition, you think? To find the total cost? Yeah, you would use addition. So 48 plus 25 plus 12. Well, here's what we're being challenged to do. Look at the entire expression. Are there 2 terms in this expression that would actually be easier to multiply or to add together first? 48 and 12. So I can use the commutative property. And on your homework, it's going to say justify your answer. That's what that means. To say which property you used, plus 25. So in parentheses, I'm going to say commutative property. And I can abbreviate, that would be fine. 48 plus 12 is what? 60 plus 25? $85. Okay? So I got my answer and I didn't even have to use a calculator. All right? Now, if you remember back in 7th grade math and Math 7, on this test, do you remember those really long problems that were on the test? But if you knew the number properties, they were extremely easy to solve. If you didn't, you had to multiply fractions and you had to do all kinds of adding and subtracting with negatives. Remember that?
Yes.
That's what we're getting at. If you know the number properties, solving problems can be much, much easier because you can apply these rules to cancel out values in numbers or to rearrange them to be easier to add together. So I want you to try to rearrange letter B on your own, on your paper. So write it down on your paper. Try to rearrange it and then solve it using mental math. Okay, so how did you rearrange them?
17 plus 13
Seven.
plus 36.
Yeah, very good. Plus 36, because 17 plus 13 is what?
30.
30 plus 36?
66.
66. 66. All right, try to do C. I know it's decimals, but we can still apply the same concept. All right, so how did you rearrange these?
3.4 plus 7.6 plus 9.7.
All right, plus 7.6. The reason we did this is because if we add the decimal values, 6 plus 4 gives me 10, which is 0, so it's going to be an even number. And I carry that 1, so what's 1 plus 3 plus 7? It's 11. Very good. All right, so that's going to be 11 now plus the last one is 9.7 gives me 19.7. Who got that? Who got that right?
20.7.
It's 21.7.
Oh, yeah, sorry. No, it's 20.7. 20.
It's 20.
No, 11 plus 9 is 20. 20.7. 20.7. Okay, any questions? Any questions on that? All right, that's it for example 1. Now in example 2, I'm going to make my substitutions and solve. But now I'm focused specifically on, once I make my substitutions, can I rearrange them to make it easier to solve using mental math? Again, number properties make it easier for us to solve the same problems that might have been more difficult. All right, so try to make your substitutions and see how you would rearrange them. All right, so we make our substitution 4 times negative 7 times 25. So what do you think, which terms would be easier to multiply first? 4 and 25. 4 times 25 times negative 7. Well, what's 4 times 25?
100.
All right, 100. What's 100 times negative 7?
Negative 700.
Negative 700. You see, we were able to do that without doing any math or working anything out on the side. I don't know how many, I know I couldn't. What's 4 times negative 7? Negative 28. Can you do negative 28 times 25 in your head? No, I mean, you can at least agree, even if you can, that it would be much more difficult than the way that we did it. 100 times 7, right? We can all agree? So that's how the number properties are helpful. Go ahead and do B. Do B. Raise your hand when you have the answer. Okay, so 5 times negative 6 squared times 20. All right, so negative 6 squared we know is negative 6 times negative 6, which gives me positive 36. Negative times a negative is a positive. You see how these concepts are kind of building? We have to know those positive and negative rules. 5 times 36 times 20. Well, now we need to evaluate which numbers could I multiply together to make it easier to solve. Very good. So I'm going to apply the commutative property. So on your homework where it says justify your steps, that's where you say commutative property and you make the change. 5 times 20 is what? 100. And look, guys, look up here on the board. 100 times 36, you multiply 36 times 1 and you bring over your 2 zeros. 3,600. 3,600. 3,600. Do you see where you went wrong?
Yes, I wasn't paying attention. Yeah, I thought it was the same thing.
Okay. All right. Do you see where you went wrong? Okay. Example 3 now. This is the example that I started to explain earlier. You are going to answer these 5 questions. Which property is illustrated? Is it commutative? Yes, you can. You can use your terms. Is it commutative, identity, inverse, or associative? All right, go ahead and answer these 5. Number 1, what property is it?
Identity.
It is identity. Again, the mirror, multiply number times 1, it's just that number. Okay? Identity and multiplication. What about B?
Commutative.
Commutative. I changed the order. What about C? Identity. Again. D. Okay, I really don't like D because it says associative, but are we ever supposed to put parentheses around our variables? No. Okay. So it is associative though, and then E is Not commutative. Well, it is commutative and associative. It's actually both commutative and associative because they changed the order. Why did they want to group those first two numbers together? Because they're easier to add together. Okay, so here's the last slide. Here's the last slide. Okay. You need to write this down on your regular paper, on your notes. Numbers and variables are not like terms.
So write it on.
You cannot add them on your regular notes. You cannot add them or subtract them, but you can multiply and divide them. Okay, so this is intro to simplifying expressions. For some reason, they kind of start introducing some of this before we actually do the lesson in 2.3. All right, so numbers and variables are not like terms. You cannot add and subtract those terms together, but you can multiply and divide them. Okay, look at example A. Everybody look up here together. How many terms do we see? We see 1, 2, 3, 4 terms in this expression. Does everybody agree? Terms are separated by operations like addition and subtraction. All right, so now of these 4 terms, I need to identify what I call like terms. Those are numbers by themselves or terms with a variable as long as it's the same variable. So we see 7 plus 3. Those are like terms, so I'm going to use commutative property to regroup them. Plus 2x plus 4x. All right? And now that I've grouped my like terms together, I can simplify. What's 7 plus 3? 10. And 2x plus 4x, I add my numbers to get 6x. And that's my final answer. I can't simplify it anymore because 10 is just a number and 6 has an x. They are not like terms. All right, so based on that, I want you to do letter B. Simplify that expression. All right, so what's 5 plus 4? 9. And what's 2a plus 5a? 7a. Who got 9 plus 7a? Awesome, awesome. All right, do C. C is going to be a little harder because you have to apply your positive and negative rules too. How did you rearrange them? How did you rearrange them, Sarah?
Negative 20 plus 16 minus 6b plus 3b.
Okay, that's perfect. Minus 6b plus 3b. Now, if you didn't quite rearrange them that way, that's fine as long as your numbers are together and your variables are together. Okay? So negative 20 plus 16. Use your positive negative rules. What do you get? Negative 4. Did you get negative 4?
Yes.
Okay. And then negative 6b plus 3b is what? Negative 3b. Who got it right? Now that one was a little harder. That one was a little harder. All right, very good. So this is where we're going to end today's lesson. Tomorrow we'll pick up on using now our number properties to simplify expressions, and we're going to especially use the associative property tomorrow.
How many problems do we get done?
And that's everything you need to know for part 1 of 2.1.